Hello students, let us continue solving problems from the chapter Permutations and Combinations for class 11. We had finished the first two exercises, so we'll continue with exercise 7.3. And the formula which you need to remember is NPR equals factorial n divided by factorial n minus r. So the first question, how many three-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated, right? So none of the digits are repeated. So the numbers are 1 to 9. So there are 9 different digits, 1 to 9, and we need to form a three-digit number. So to form a three-digit number from 9, I need to choose 3 of them. So 9p3. So therefore it's going to be factorial 9 divided by factorial 9 minus 3, which is 9 into 8 into 7 into 6 factorial divided by 9 minus 3, 6 factorial. So that gets cancelled. So 9 into 8 into 7 gives me 504 ways, or 504 different numbers can be formed. Second one, how many 4-digit numbers are there with no digit repetition? So there are 10 numbers 0 to 9, and I need to find the total number of 4-digit numbers. So 4-digit numbers, so you have the thousands place, hundreds place, tens place, and the units place. So there are 10 digits, that is 0 to 9. So in the thousands position, I cannot place 0, because if I place 0, it becomes a 3-digit number. So I only have to select numbers from 1 to 9. So there are 9 possible ways. So I select one of them. Now in the hundreds place, I have the remaining 8 plus the number 0. So again you have 9 possible ways. So it's going to be 9. So among these 9, I've chosen one here. So in the tens place, it's going to be 8. And then in the units place, it's going to be 7. Right, very simple. So it's 9 into 9 into 8 into 7. So the total number of possible numbers is 4536. 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? So we have a 3-digit number. So let me consider a 3-digit number. So this is the units place, tens place, and the hundreds place. A 3-digit even number. So if I have to form a 3-digit even number, in the units place, I can only have 2, 4, or 6. Right? So therefore, there are 3 possible ways, or it's going to be 3p1, which is going to be 3 factorial divided by 2 factorial, which is 3 ways. Right? So this is going to be 3. There are 3 ways of selecting the numbers for the units place. Now I've selected one of them. So the remaining, you have 5 digits left. So you have 1, 2, 3, 4, 5, 6 digits. Among 6 digits, I've chosen one of them. So there are 5 digits left. So among 5, I have to select 2. So it's going to be 5p2 into 3. So it's going to be factorial 5 divided by 5 minus 2 is 3 factorial into 3, which is 5 into 4 into 3, which is 60 ways. Again, a simple problem. So let's move on to problem 4. Find the number of 4-digit numbers that can be formed using digits 1, 2, 3, 4, 5 if no digits are repeated. So you have numbers 1, 2, 3, 4, 5. So now I need to find the number of 4-digit numbers. So among these 5, I have to select 4. So it's going to be 5p4. So which is factorial 5 divided by factorial 5 minus 4 is 1 factorial. So this is factorial, which is 5 into 4 into 3 into 2 into 1, which gives us 120. The next part is how many of them will be even. Now for even, I have a 4-digit number. Now if the number has to be even, then the units placed can only have the digits 2 and 4, right? So there are 2 ways. So 2 or 4. So there are 2 ways here. right? So that means it's going to be 2p1, and then remaining out of 4 I have to select 3. So it's going to be 4p3 into 2p1, right? So it's going to be factorial 4 divided by 4 minus 3 is 1 factorial into factorial 2 divided by factorial 1, which is again 2. So this is factorial 4 into 2, which is going to be, the answer is 4 into 3 into 2 into 2. So 12 into 4 gives us 48 ways. Problem 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So there are 8 people, and then we have to choose a chairman and a vice chairman. So that means we are selecting 2 out of 8. So it's going to be 8p2, which is going to be factorial 8 divided by 8 minus 2 factorial, which is 6 factorial, which is 8 into 7 into 6 factorial divided by 6 factorial, which gets cancelled. So 8 into 7 is 56 ways. Question 6. Find n if n minus 1 p3 is to n p4 equals 1:9. Right? So we have to use this formula. NPR equals factorial n divided by factorial n minus r. So instead of n, I have n minus 1 factorial divided by, so this is going to be n minus 1 minus 3. So minus 1 minus 3 is going to be minus 4 factorial divided by n factorial divided by n minus 4 factorial equals 1:9. So n minus 4 factorial gets cancelled. So this gives n minus 1 factorial divided by n factorial can be written as n into n minus 1 factorial equals 1/9. So n minus 1 factorial gets cancelled. I cross multiply, 9 equals n. So the value of n is 9. A very simple problem. Problem 7. Find r if first one 5pr equals 2 into 6pr minus 1. So let's use the factorial formula. Factorial 5 divided by this is 5 minus r factorial equals 2 into 6 factorial divided by 6 minus of r minus 1 factorial. So this is 5 factorial divided by 5 minus r factorial equals 2 into 6 factorial can be written as 6 into 5 factorial. And here this is 6 minus r minus of minus 1, which is plus 1. So this becomes plus 1 plus 6. So you get 7 minus r factorial. So 5 factorial gets cancelled. So I bring the 7 minus r factorial to the other side, divided by 5 minus r factorial equals 12. Now this can be written as 7 minus r into 7 minus r minus 1. So 7 minus 1 gives 6. 6 minus r into, you get 5 minus r factorial divided by 5 minus r factorial, right, which is equal to 12. So 5 minus r factorial gets cancelled, equal to 12. So multiply these two, you get r square minus 13r. 7 into 6 is 42 equals 12. Bring 12 to the other side. 42 minus 12 is 30. R square minus 13r plus 30 equals 0. So find two numbers such that when you add them you get minus 13. Two numbers when you multiply you get 30. So what are those two numbers? So it's very simple. It is minus 3 and minus 10. Right? So split this as r square minus 10r minus 3r plus 30 equals 0. So r into r minus 10 minus 3 into r minus 10 equals 0. So you have r minus 3 into r minus 10 equals 0. So r equals 3 or 10. Now if you observe, I have 5pr. So the value of r cannot be greater than 5. So therefore, I cannot have 10 as the answer. So R has to be equal to 3. Second one, 5PR equals 6PR minus 1. So we have the same expression except that you do not have 2 here, right? So again, we are left with the same thing. So you get 5 factorial divided by 5 minus R factorial equals 6 factorial divided by again 7 minus R factorial, right? So again, this can be written as 5 factorial equals 6 into 5 factorial divided by 5 minus R factorial. Again, I write 7 minus R factorial is 7 minus R, 6 minus R into 5 minus R factorial, which gets cancelled, and 5 factorial also gets cancelled. So you have 7 minus R into 6 minus R equals 6. So you have R square minus 13R plus 42 minus 6 equals 0. So the same expression except that here you had 12 and there you get 6. So R square minus 13R plus 36 equals 0. Again, find two numbers such that when you add them, you get minus 13, multiply, you get 36. So very simple, it's minus 9 and minus 4. So split this as minus 9R and minus 4R. So R square minus 9R minus 4R plus 36 equals 0. R into R minus 9 minus 4 into R minus 9 equals 0. So R minus 4 into R minus 9 equals 0. So R equals 4 or 9. So again observe that n is 5 here in this case. So R cannot be greater than 5. So therefore the value of R is 4. Question 8. How many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once, right? So how many letters are there? There are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters. Okay, so the number of letters used to form the word is 8. So definitely I have 8p8. So which is going to be 8 factorial. So which is going to be 8 into 7 into 6 into up to 1. So you get this as 40320 ways. A very simple problem. Ninth one, how many words with or without meaning can be made from the letters of the word Monday? So I have MONDAY, assuming that no letter is repeated. If first case 4 letters at a time, so you use 4 letters at a time. So here I have 6 letters or alphabets. So if I'm using 4, it's going to be 6p4. Very simple. So you have 6p4, which is factorial 6 divided by factorial 6 minus 4, which is 2 factorial. So which is 6 into 5 into 4 into 3, which is 360 ways. Second one, all the letters are used at a time. So if all the letters are used at a time, it's going to be 6p6, which gives a 6 factorial, right? Very similar to problem 8. So 6p6 is going to be 720 ways. So 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Then third one, all letters are used, but the first letter is a vowel. So you have 6 alphabets, but the first one is a vowel. So you have A and O, right? So there are 2 possible ways of filling in the first one. So you have 2, and then you have remaining 5 here, right? So among the remaining 5, I have to choose 5 more. So it's going to be 5p5. So it's going to be 2 into 5 factorial. So which gives the answer as 240. So you have 240 ways. 10th one, in how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? So we have the word Mississippi. Now let's identify how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 alphabets or 11 characters. Okay, some of them are repeating. So I find that the letter I repeats 1, 2, 3, 4 times. The letter P repeats 2 times, and the letter S repeats 1, 2, 3, 4 times here. Okay. Now, how many different permutations are possible? So the total number of permutations, so number of permutations is definitely 11 factorial divided by the factorial of the letters which are repeating. So I find that M of course occurs 1, so it's going to be 1 factorial. I occurs 4 times, so it's 4 factorial. S occurs 4 times, so it's 4 factorial. P occurs 2 times, so it's going to be 2 factorial. So therefore, when you calculate this, 11 factorial divided by 1 into 4 factorial into 4 factorial into 2 factorial, we get a huge number which has been calculated. You have 34,650. Now, the question is, in how many of the distinct permutations of the letters Mississippi do the 4 I's not come together? That means all the 4 I's are not together. So now let us try to find the number of permutations where all the 4 I's come together. So this gives the total number of permutations where many combinations have 4 I's together. So I have to eliminate the number of combinations which have 4 I's together. So let us consider all the 4 I's as one segment, right? As one segment. So you have 11 characters. So 11 minus 4. So 11 minus 4 plus 1, because all the 4 I's I'm considering it as one character. So 11 minus 4 is 7 plus 1 gives us 8. Right? So here all the 4 I's are considered as one character. So here the number of permutations with all 4 I's together. So all 4 I's together equals, so you have 8 factorial, right? Because 7 plus these 4 I's are considered as one unit, 8 factorial divided by, now P occurs twice, so 2 factorial, S is also occurring 4 times, so divided by 4 factorial. So you get this as 840. So these are the number of possible permutations where all the 4 I's occur together. So this has to be subtracted from 34,650. So to find the number of permutations where all the 4 I's do not occur together, you have to write this, is 34650 minus 840. So when you subtract both of them, you get 33810. Right? So an interesting question. Question 11. In how many ways can the letters of the word permutations be arranged? If the first one, the word starts with P and ends with S. So how many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 of them. Right? So now I need to consider again a word with 12 characters where the first one is P and the last one is S. It's fixed. Right? And then you have 10 in between, right? So P and S. So there's only one possible way, because the first character has to be P and the last has to be S. So therefore the total number of permutations, so number of permutations here is going to be 10 factorial divided by, so here let us try to find out if there are any alphabets which are repeating. So I find that the alphabet T occurs 2 times, so it's going to be divided by 2 factorial. So 10 factorial divided by 2 factorial gives us 1814,400. 2. If all the 5 vowels are together, right? So all the 5 vowels are together. So how many vowels are there? A is present, E, I, O, U. All the 5 of them are there. So we consider them as 1 unit, right? So 12 minus 5 is 7 plus this unit, which is going to be 8, right? So now there are 2 things. First, let's find out what are the total number of permutations, considering this as 1 unit. So it's going to be 8 factorial divided by 2 factorial, because t occurs twice, so it's going to be 8 factorial by 2 factorial, which is 20,160. Now these 5 vowels, though they are together, they themselves can be permuted, right? So the 5 vowels can themselves be permuted. In how many ways? It's going to be 5p5, or it is 5 factorial. So this is 120. So the total number of permutations, so the total permutations is going to be 120 into 20,160. So you get a huge answer, which is 2419200 ways. So in the previous case, you had 4 I's which were considered as 1 unit, but remember, all the alphabets are similar, right, are the same. So even if you permute them, there will not be any difference. But here, these 5 vowels are together, but they themselves can be permuted, right? So therefore you will have a variation here. So therefore here I have to consider 5p5, that is the 5 vowels being permuted. Part 3, there are always 4 letters between P and S. So P and S, between them you have 4 letters. So how many letters are there? There are 12 letters. So let me write them. 1, 2, the positions 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 positions. So now if P is present in position 1, then S can be present in position 6, or if S is present here, P should be present here. So it's going to be 1, 6. And how many possibilities are there? There are 2 possibilities, PS and SP. What about the next one? 2 and 7. So in between there are 4, 3, 4, 5, 6. So it's going to be 2, 7. Again, the next one is going to be 3 and 8. Observe, it's going to be 3 and 8. Again, there are 4 in between. The next one is going to be 4 and 9. So in between you have 4 alphabets, 4 and 9. And then you have 5 and 10. And then 6 and 11. 6 and 11. Again, in between you have 4 of them. And then the last one being 7 and 12. So there are how many ways? 1, 2, 3, 4, 5, 6, 7. 7 ways. And in each way there are 2 possibilities. One is PS, the other one is SP. So it's going to be 2 into 7, which is going to be 14 ways here. So now we need to calculate the number of permutations. So out of 12, I have already calculated for 2 of them. So for the remaining 10, it's going to be 10p10 divided by the alphabet T occurring twice, which is 2 factorial. So this is going to be 1814400. And what about the total number of permutations? So the total number of permutations is going to be 14 into this number, 1814400. So I've already calculated, it's a huge number. It is 25401600 ways. So very interesting problem. So this completes exercise 7.3, and in the next video segment we shall solve the problems of the exercise 7.4, wherein we'll be solving problems related to combinations. I hope you have found the lecture useful and interesting. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.